Liking this video will help this channel to grow. So please go ahead and give this video a like. Welcome to section 2 of our lessons on function. Today we'll be exploring composite functions. I hope that you found section 1, which was focused on introduction to functions, beneficial and is fired up for this part of the lesson. As always, these lessons are accompanied by independent practice worksheets which you can find in the description of each video. So now let's define composite functions. When we put the result of a function into another function, these are called composite functions. So for example, if I'm given f of g of x, this means I need to do g of x first, and then I'm going to put the answer to that into f of x. So the order of how the functions are applied is very important. So for example, as I said, I have to do g of x first, and then when I get the answer, I put that answer into f. I cannot at all do f of x first. So that's what we mean when we talk about the order in which functions are applied is important. We must follow a particular order. Beautiful. Now we're going to look at how to evaluate numeric functions first of all, and then after we're going to look at algebraic functions. So in order to evaluate numeric composite functions, step 1, and I encourage you to write this down. So use the number to be evaluated as the input for the inner function, and then you're going to substitute that number into the expression that you're given. Step 2, find the output for the inner function, which we talked about in part 1, and then substitute it into the expression for the outer function. So whenever you find the value for the first function, the answer you get is what you're now going to be substituting into the outer function. So third and final step is to find the output for the outer function, and you could get multiple functions. So what you would do at this stage is just keep repeating the process that we have outlined in the previous steps. So let's say you got f of g of h. You'd have to do h of x first, then put that into g of x, then put that into f of x. So it's a repeated process here. Now we're going to look at 3 examples to qualify those steps that we talked about. So here we're given 3 functions. Given that f of x is equal to 4x minus 1, g of x is equal to x squared minus 3, and h of x is equal to x divided by 2. We're asked to find, first of all, in part A, what is f of g of 2. So here the x is replaced with 2. So what we would need to do here, based on our steps we've discussed, is to find what is g of 2 first. After we've gotten the answer to that, we're now going to put the result into f. So let's follow the steps. So first of all, I'm going to go ahead and I'm going to find what is g of 2. So we're working with the function g of x, which is x squared minus 3. So I always love to write my function out first and then go on to do the solution. So I'm just going to rewrite what is g of x here first. So g of x is equal to x squared minus 3. Now I can go on to find g of 2. So I'm going to replace the x in the function with the value 2. So essentially I'm doing 2 squared. So x here is being replaced with 2. So 2 squared minus 3. So now time to calculate. 2 squared is equal to 4. 4 take away 3 is equal to 1. A nice one to substitute into f. So now I've got it, I can now substitute this 1 into the function f. So I'm going to do f of g of 2 is equal to, I'm going to do 4, but instead of the x that I'm given here, I'm going to replace it with the value I got from my first answer, which is 1. So I'm doing 4 multiplied by 1 minus 1. So let me just rewrite the function here. For f of x is 4x minus 1. So I'm replacing the x here with the 1 I got from the first expression there. So go ahead, 4 times 1 is 4, minus this one here is 3. So the final answer for f of g of 2 is equal to 3. Beautiful. You can see here, once we break it apart, it's really what we did in our first lesson on our introduction to functions. Substitute the value we're given for x into the first function. The answer we get from that, we substitute that in the second function. Absolutely fantastic. So now we go to part B, where now we're asked to do h of g of 9. This simply means we need to do g of 9 first. When we get our answer from that, we're now going to put that into the function h. So let's start. So I'm going to rewrite. So g of x, I want to write that out first of all. So g of x is x squared minus 3. Now I need to do g of 9. This simply means where x is here, I'm replacing that with 9. So it's going to be 9 squared minus 3. So 9 squared is 9 times 9, which gives me 81. Take away 3. So 81 take away 3, that will leave me with 78. Beautiful. So this means I should now use this 78 and I need to substitute that into the function h. So I'm going to write out what is h of x first of all. So h of x given from this function here is x divided by 2. So h of g of 9 is equal to, so the answer I got from g of 9 was 78. So I need to do 78. So I'm replacing that x in h of x with 78. And then that's divided by 2. So basically my answer will just be what is half of 78. So we break this down. Half of 70 is 35. And half of 8 is 4. So 35 plus 4 is 39. So we can see 39 plus 39 gives us 78. So the entire answer for h of g of 9 is 39. Beautiful. You just need to take your step and follow your order of operations. Next example here is g of h of minus 12. This means I need to work out what is h of minus 12. So I'm going to go ahead and I'm going to write out what is the function h of x. So h of x is equal to x halves or x divided by 2, which means that h of minus 12 is equal to, so I'm going to replace x for minus 12 and divide that by 2. So half of minus 12 is minus 6. So now I need to put this answer into the function g. So I'm going to go ahead and write the function g of x, which we were given. G of x is equal to x squared minus 3. Now I need to substitute this x here for minus 6. So I love to write all I was given, so I'm just going to rewrite that and then do my substitution. So x squared, the x now is going to be minus 6. Importantly, put that in bracket because I'm not just squaring the 6, but I'm squaring the minus 6. And then I've got minus 3. So squaring a negative gives us a positive. So negative 6 times by negative 6 will give me positive 36. So 36 take away 3 gives me 33. So the final answer for g of h of minus 12 is 33. Absolutely fantastic 3 examples there on the numeric. Now we're going to move over to looking at the algebraic composite functions. So 3 quick steps here. Obviously, I missed a count there because I got 1 step 2, and step 2 again. So that should be step 3 for the final one. So in order to evaluate algebraic composite function, step 1, pretty much the same. We need to take the most inner function and substitute it into the next outer function. So this one, we are substituting one function into the other function. So in the numeric, we substituted a number into a function. This algebraic, we are substituting the expression of one function into the other function. And then step 2, we simplify the expression as appropriate if it can be simplified. And then if we should have more, then we will repeat for any other outer function. But most times we will get probably 1. For more complex questions, you will get maybe 3 functions to put 1 into 1 into 1. Okay, but pretty much the same principles apply here. So I've got one example here where we're given that f of x is equal to 4x plus 7 and g of x is equal to 8 minus 2x. We're asked here in part A to find what is g of f of x. Notice no numbers given this time in part A. However, in part B, there is a hence. Hence, find the value of g of f of 8. Now, whenever hence comes into a question, it means that having done the first question, use it to do the second. That's what the word hence means. It's a follow-up question. So we're asked to find g of f of x. This means that I'm going to put the value, the function f of x, into the function g of x. So the most pretty simple way to do this is to first of all write out the function g of x. So basically, let me put an arrow here. So the value of f of x should be placed into the function g. So I'm going to write g of x first. So g of x was given to be 8 take away 2x. So what this means here is that I'm now going to put the value of the function f of x, which is 4x plus 7, wherever x is in g of x, I should replace this x here with all of the value of f of x. I'm putting a little bit more emphasis on this because I know this can be tricky. So what I need to do for g of f of x, I'm going to write 8 minus 2, but instead of this x here, I'm going to now replace it with all of the function f of x. So bracket, I'm going to now write 4x add 7. So this x is replaced by 4x plus 7. Now in step 2, we talked about simplifying. So what we need to do here now is to use the minus 2 to expand the bracket. So I've got 8 minus 2 times 4x is minus 8x. And minus 2 times by 7 is minus 14. Now I need to simplify. So I'm going to keep my variable first. So that's minus 8x. Now I need to do 8 minus 14, which is minus 6. And that is my final answer. Now, in order for you to be more fluent at this, I would suggest that you watch the videos on expanding brackets. So we've looked at expanding binomials and polynomials. You could go back and look at those. It will be very much helpful in unlocking these questions where you have to expand your brackets. So now we're going to do the part B, which is our hence. So having what this means, hence find the value of g of f of 8. It means then, now that you have found g of f of x, substitute 8 into that answer for a final answer. So g of f of x is equal to minus 8x minus 6. That's the answer we got. So what this is telling us to do is where x is, we should replace it with 8. So we're going to do minus 8 brackets. We're replacing this x here with 8. And then we also had minus 6. So what we need to do now is to simplify. So minus 8 times 8 is minus 64. Minus 64 minus 6 is equal to minus 70. Now, when you do the hence part, you are going to now receive a final numerical value. When you substitute a function into another function algebraically, you will always get an algebraic expression. However, when you substitute a number into that, you now can see you have a numerical answer, no variables at all. Beautiful. So we just have another question to do, and then we are going to do our key takeaways. Brilliant. So here we're given 3 functions. We're told that f of x is 4x minus 2, g of x is just x squared, and h of x is x divided by 2 plus 1. We're asked to find h of f of x, and then substitute 12 for that by finding h of f of 12. Very tongue twisting to say. Okay, and then for part B, we need to find g of f of x and hence g of f of 2. And then after we've done these, you could also pause the video here and try them on your own and see how well you've come along. And then we'll do our key takeaways. Brilliant. So here we're going to first of all put the function f into the function h. So I start off by writing what is the function f. So f of x is given to be x divided by 2, add 1. I now want to find h of f of x. So I'm going to replace the x in h of x with the value of f of x, which is 4x minus 2. So if you look here, f of x is 4x minus 2. So I'm replacing that with the x that's here. I'm using it to replace. Please don't forget that must be divided by 2 and then add 1. So now all I need to do is to simplify. So I'm dividing 4x minus 2 by 2. So half of 4x is 2x. And half of minus 2 is minus 1. And then I need to add 1 to that. So we are simplifying 2x. You can see here minus 1 plus a positive 1 cancels out to 0. So the answer for this is just 2x. So now I'm just going to do the other part by substituting 12 into this. So h of f of 12 is equal to 2 times by 12. So I'm replacing this 12 here for the x here. So 2 times 12 is equal to 24. Absolutely brilliant. So you can see I've mastered my substitution. I know how to substitute one function into another. It's really easy for me to find out the answer by just doing my numerical calculations. Absolutely brilliant. Final question here now. I'm going to do g of f of x. So since I'm going to put f into g, I'm going to write g of x first. So g of x is equal to x squared. Nice one. So I need to put the answer for f of x, the value for f of x, and square it. So x here will be, so it's 4x minus 2. I need to square that. Brilliant. So remember, when I'm squaring, it means I'm multiplying the value by itself. So again, links nicely to that lesson on expanding double brackets. So I need to do 4x minus 2, and I'm going to multiply that by itself. So I'm expanding a double bracket. So 4x times 4x, that's 16x squared. 4x times minus 2 is minus 8x. Minus 2 times 4x is also minus 8x. And then negative 2 times negative 2 is positive 4. So now I need to simplify. So I've got 16x squared. You can see this is a quadratic. The highest power is a 2. Minus 8 is minus 16. So that's minus 16x for the b term and 4 for the constant. So that is the answer for that question. Last step is to do the hence. So we're going to replace all the x's in this for g of f of 2. So let's write that out. So g of f of 2 is equal to 16 bracket 2 squared. Remember, my x here was squared. Minus 16 bracket again. For x, I'm replacing that with 2, add 4. So I'm just going to now simplify. So I need to multiply first of all. 2 times 2, which is 4, and then I need to do 16 times by 4. So let me just do that here. 16 times by 4. 6 times 4 is 24. 4 times 1 is 4 plus 2, so that's 64. All of this gives me 64 minus 32. 16 times 2 is 32 plus 4. So we just need to get a final answer here. So I can do, first of all, 64 take away 32, which is 32. 32 plus 4 gives me 36. So my final answer is 36. Absolutely fantastic. So what I need to do now is our key takeaway. Absolutely brilliant. So first of all, guys, we talked about composite functions. We say when we put the result of a function into another function, these are called composite functions. We can have numeric composite functions and also the algebraic composite functions. So if I'm given, for example, f of g of x, this means I do g of x first and then put my result in f of x. And again, the order which we do them in matters. It's very, very important. We talked about the fact that we use the number evaluated as the input for the inner function and then substitute it into the expression that we're given. So that means when we're given a numeric, we just substitute the value we're given in place of x into the function. Then when we get our answer, we substitute that answer into the other function. However, if it's algebraic, we simply put the value of one function into the other function and we simplify, leaving us with an algebraic expression. If a question then goes on to say, hence, find the value of and give us a number, we substitute the number given into the expression that we have been given or that we got when we combined those two functions. Beautiful. Now the advantage that you have is that you can watch the video over and over. You can pause, you can do a question over, you can try on your own, and also you have additional questions in the description of the video that you can practice on, and also the answers to those questions. And we have further exam style questions over on TikTok as well. Remember, like, share, subscribe, hit the notification bell if you haven't, and also make sure you're looking out for part 3 of this lesson, where we're going to look a little bit on rearranging formula to prepare us for inverse functions. Absolutely fantastic. So proud of you for getting all the way to the end. Thank you so much for watching.